is Basic, the Atari 8-bit podcast.
This is an interview episode of Antic, the Atari 8-bit podcast. I'm Kevin Sevitz. David Stoutemyer was co-founder of The Software House, a company that specialized in mathematics software for several computer platforms. The company published 3 programs through Atari Program Exchange. Algicalc and Polycalc first appeared in the summer 1982 APX catalog for $22.95 each. Algicalc was described as a valuable tool for students and teachers of algebra and calculus and for professionals who want a quick way to perform operations in symbolic algebra and calculus. It won 3rd prize in the education category in that catalog. Polycalc was described as a computational tool for performing symbolic algebra and calculus operations. It differs from Algicalc in that Polycalc supports polynomials that are generalized to permit fractional and negative powers of variables, and the program can use many unassigned variables, whereas Algicalc can only use one. However, Polycalc is essentially a polynomial system rather than a rational expression system. Their 3rd Atari program was Calculus Daemon, which was first available in the fall 1982 catalog. It also cost $22.95 and was described as a comprehensive tool for automatically deriving symbolic partial derivatives and indefinite integrals of expressions. This interview took place on January 29, 2016. I would like to know the story of the Software House, and how you got interested in computers and how you started the company, and we'll kind of go from there, if that's okay.
Sure. I was a professor teaching the computer courses in the electrical engineering department at the university here. And,
University of Hawaii?
University of Hawaii. And the University of that department was very early in using and developing the ARPANET, the precursor to the Internet.
Mm-hmm.
And I had the good luck to be able to use the ARPANET. And with it, I was able to connect to the University of Utah, where the reduced computer algebra system was developed, and MIT, where Maxima was developed, both very powerful computer algebra systems, and I was using them for my research and became enamored of them. And I wanted my students to be able to use this sort of powerful tool as well. But at that time, computer algebra was one of the most demanding possible things you could try to do with a computer. It usually only a few people could simultaneously be doing that on even a mainframe, and only mainframes could host them. So I despaired of being able to do that. But about that time, the first microcomputers were becoming available, and I thought, here's a machine that no one, there's no bean counter giving you a certain amount of CPU minutes per class and so on. So you have it all to yourself. If we can fit a computer algebra system on a microcomputer, that's within reach of having a lab full of those, and so the students can actually use it and experience this tool. And our department got some early S100 bus microcomputers, Cremento computers. They had 64 kilobyte address space, and they were based on the Intel the 8080 chip.
Mm-hmm.
And so I thought, here's an idea. And so I had an idea for developing one using, in fact, the very same mechanism that was used for the Atari Calculus Daemon program. And I started out writing assembly language program to do that. And then I met up with a student there who had developed a Lisp program for the same platform. And I thought, wow, that'll be much easier. Lisp is the language that most of the major computer algebra systems had been written in. It's very well suited to the purpose. So we got together, and he further developed his Lisp, and we started writing a computer algebra system called MuMath for that. And he was sort of just semi-employed, so we formed a company, and he did most of the programming and spent the time, and finished up this program called MuMath, and started to sell it. And we published an article describing it, one in Byte magazine and one in Creative Computing magazine, and that got some notice, including the notice of a person named Greg Witten, I think it is, at Microsoft. And he said, we ought to maybe think about publishing something like this. And so he told Bill Gates and Paul Allen, and on the way to Japan for some business, they stopped and visited us and took a look at our product and made an offer to republish it. So we kept publishing it too, but they also republished it, and that gave us a lot of notice too. It turned out that the big popular 64 kilobyte computers were not the S100 bus ones, but they were the TRS-80, which used the same processor, and the Commodore and Commodore PET, and the Atari, and the Apple II, which used the 6502, was it? Yes.
6502.
Yeah, and so, but we did fit on the TRS-80, although some adaptation was needed because they didn't use the same. There were differences. The IOs, for example, we used the CPM operating system, and they had their own that was bundled into their Microsoft Basic. So they did a little adaptation for us, and they took care of the TRS-80 sales, and that worked out pretty well. But it was not a flagship product for them. The market for computer algebra is way, way smaller than for virtually any of the other popular things that were being done then. Mm-hmm. Games and word processing and so on. And so we eventually didn't renew the agreement, but that helped us get some notice. And at one point, there were three processors that were sort of being considered for the next generation. And one of them was the 8086 or 8088, and IBM happened to choose that. We decided we should move on to a 16-bit, a larger computer as home computers evolved. And a company named Godbout manufactured a board that you could stick in the S100 bus that had the 8088 or 8086 chip on it. So that gave us a quick way to cross-compile and develop for the 8086, and which was not the nicest processor of the three that were sort of being considered. The Motorola 6800 was a better choice, a nicer instruction set, as was the I think National Semiconductor had a nice one, and TI had a nice one too. But when IBM chose that one, it took off. It became the first one to be successful. So we got lucky on that, and our next we moved MuMath onto that. It had a larger address space, which helped us out a lot. And we also realized that the old command line interface was passing, and so we decided we wanted to make a better interface and a whole new product. We learned a lot in writing MuMath. It was a technical success, but not a huge marketing success. It kept my partner and his wife well fed and so on, but it wasn't a takeoff sort of thing. And so we started designing a second product called Derived, and it had its own interface, its own GUI, but it was basically character-based, but window character-based is what you might call it. Microsoft Windows was sort of toying with the early versions, but they weren't well received, and justifiably not. So we had our own, and it was an easy interface to learn. The formulas were displayed in 2 dimensions, so it was more legible and easier to comprehend. And it really took off. It got some very good reviews, and so all of a sudden that was our first really successful product, and our most successful one.
What was it called?
It was called Derived.
Derived. Okay.
All through this, my roots were in education, and all through this, I wanted to make computer algebra accessible, and still, we weren't still to the point where every student had his own laptop or anything like that. In fact, laptops weren't around. The first luggable computer was Osborne, and we got lucky there too. Someone at Osborne, who was an engineer, thought Osborne bundled a lot of software with their luggable, and they decided they wanted to have a contract to have Derived bundled in and on every Osborne, and that was a nice big boost for us to do that as well. Osborne eventually failed as a company because they announced a new model too soon before they were ready, and people stopped buying the old model, so dried up. But they inspired Compaq and K-Pro, which were two nicer luggables at that time. But all along, I wanted to be in the hands of students in a classroom in a way so they didn't have to go to a special lab, because usually, hey, let's try this. You don't want to get out of class and go to a lab and get sort of reoriented and then come back again. It's just organizationally a lot of overhead to do that. So I really wanted it on handheld calculators, and I'd experimented putting toy versions on calculators, including a simpler thing called PicoMath. And I'd also, anytime we went to a trade show, I'd talk with the people like Texas Instruments and Hewlett-Packard. I actually went up and visited Hewlett-Packard several times and put a prototype on a one-line basic calculator they had. I don't remember the number anymore. It never was a marketing success. It was just too pricey for what it did. But it was sort of a demonstration that it could be done. They later came out with a product of their own that had some computer algebra in it, a handheld one. I finally was successful with TI. The right person was there at the trade show, and we agreed to work together. So I wrote an entirely different system for it that was based on this idea that I'd really originally started with, this sort of stack-based computer algebra system. And somewhere in there, I was in Palo Alto for a year on sabbatical, and the Atari headquarters was nearby, and I went down and talked with someone, and we arranged for me to adapt my ideas for this Calculus Daemon program. So I went there for about a month. I went there every day they had a room with about a dozen Atari 400s and 800s, and it was for developers. Developers were using them to write their programs, and just sat down and implemented this Calculus Daemon program for their software arm. I don't remember what they called it.
The Atari Program Exchange.
Yes, that was it, yeah. And I don't remember the name of the person I dealt with there, but I remember him being very cordial and nice and receptive, and they did a nice job on publishing it and so on. It never, Atari, I don't think, lasted a whole lot longer after the program came out, and it was the pricing and the pricing of those programs and the royalty rate was rather low, so we never made any real money off of it. It was a labor of love, and I do occasionally get in contact. Someone contacts me. They still use their Atari 400 or 800 or a simulator of it, and learn about the program and get in touch with me. But that's sort of the history of it.
Nice. I was researching this morning. I saw that you had 3 programs you published through the Atari Program Exchange. Algicalc and Polycalc showed up first in the summer 1982 catalog, and then Calculus Daemon showed up in the fall 82 catalog.
Okay.
So there you go.
Yeah, the Calculus Demon was more general purpose, but with the limited amount of memory, you couldn't do any one of the things that it could do as well as you could with a program that was devoted entirely to that task. So the Polycalc was devoted entirely to dealing with polynomials, and then what was it? Algicalc was rational functions.
Nice. I hadn't heard before that Atari had just a place where random developers could go and work in a lab. That's kind of interesting.
Yeah, I suppose that this person alerted me to it. It was just a short drive from my home, so it was very convenient. I really didn't I didn't expect to do anything further with Atari computers, so I really didn't relish buying one.
Sure.
But so it was helpful in that regard that I could just go down there and use it.
Nice.
I do remember I got an Atari 400. I think it was maybe an award for the program or something, and so I had an Atari 400 in the end. But that was after I developed the programs.
Mm-hmm. What did you use it for?
Not much of anything, because by then we were already working on Derived and so on. I think there was some Spanish lessons, and I think that I tried talking my children into learning Spanish using the Spanish lessons, but not to much avail.
I was looking around this morning, and I see that Derived is still a thing. That there's an international Derived user group, and people are still into it.
That's very much so. When Texas Instruments, Texas Instruments put computer algebra on one of their handheld calculators on a license. They licensed our technology, and at some point they didn't want to see a infinite stream going indefinitely. They wanted more control, so they bought a company. And they continued to sell Derived as well. But their handheld computer algebra, they also decided for consistency, they wanted a version that ran on desktops, on the Macintosh and on Windows, Microsoft Windows. And so they developed a version for that. And it was confusing to their customers to have, for the desktops, to have two very similar products that were not consistent with each other. The syntax and the semantics weren't consistent. So they discontinued support of Derived, but it's a very loyal group, cadre of expert users, and very loyal. They continue to have meetings. They have a wonderful newsletter, the Derived newsletter, that people contribute these amazing programs they've written. And I could email you the URL for that Derived newsletter.
I am looking at it right now, actually.
Oh, okay.
I'll put a link in the show notes. So being bought by TI, that must have been exciting, scary.
It was. We were not businessmen, and we never really went out for like rounds of capitalization with venture capitalists and so on. We were pretty naive in that way. And so we always stayed rather small. I think at the largest we were 7 employees, and we didn't even have most startups sort of have an exit plan, and they're thinking about going public or being bought out right from the beginning, and that never even occurred to us. But so when TI hinted around that that's what they wanted to do, we said, we're happy. We were doing this, just enjoying ourselves, but we worked out an arrangement that was satisfactory to both of us.
Nice. What do you do today?
I'm retired. I worked for TI for about 4 or 5 years to help train their team to maintain and improve the computer algebra. And then I retired and worked for them as a consultant for a few more years, and I'm genuinely retired. And I resigned from the university some years ago. I'm still an adjunct professor there. But mostly what I do now is, now that I no longer have teaching duties and no longer have the pressure of commercial development, I'm going back to the research that I never got done when I was a professor, but I had these ideas and never managed to have the time to follow up on them. So I'm just simply doing research on computer algebra and publishing it and having a great time.
Awesome. I think I have what I need. David, thank you very much.
Okay. Bye then.
If you enjoy these interviews and would like to contribute something, I encourage you instead to donate to one of our favorite organizations, the Internet Archive, at archive.org. The Internet Archive is a nonprofit digital library with the stated mission of universal access to all knowledge. They've done incredible things to preserve computer history, including hosting thousands of programs in an in-browser Atari emulator, creating the Wayback Machine, and offering full-page scans of countless Atari computer books and magazines. Make your tax-deductible contribution at archive.org/donate.